So I'll be explaining reversing a linked list using recursion. So this is the code right here. It's pretty short, but it can get a little bit confusing, and no one really explained it stack by stack, line by line. So here I am. So if you're not familiar with the recursion, it's just a function calling itself. Typically, yes, it would be an infinite loop, but you have a break statement right here, and this makes it so it's not an infinite loop, right? Because you have a case where it actually breaks. So in this case, we have a linked list that's passed here. The first part of it is the head, which is 1. So on the first line, we're checking if head next is null pointer, and it is not. It is 2. So this does not return head. And we call this line, which is just the function calling itself. This is the recursion. So we go to next. We check is next null pointer. Nope. 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 So it goes 5 times until we reach the 5th one, and here it is null pointer, right? And for null pointer. So what happens is this gets returned, head gets returned, and the rest of the code does not run for this instance, the 5th instance. Now the rest of the code needs to run. So on all these instances, the function called itself, but it still has this code to run over it down here. So here's where we are. We're on 4 now. 5 was returned to 4 on this line, reverse list, head next. Here, return head. So 5 gets returned to 4, right? So here on the fourth time the function is called, new head is equal to 5. And now this, you'll notice that this will stay the same all the way up the list, because this isn't really changed. This is just so we get the new end of the list for the function. And this is what we're getting here, return new head, which in this case is 5, because this is the end of it, which is the new start. Okay, so this is the part that gets a little bit confusing, and typically you have this part right here, head next is essentially this, right? And this is all people will tell you. 5 now is 4, but it's kind of confusing. How is 5 4? How is it next? Isn't next null pointer, right? So next equals head is essentially setting itself. So we're on 4, right? Next is 5. Next is null pointer. So 4 is set here. 4. Like I said, normally you would just visualize it like that, but for even better visualization, we'll just be crossing it out here. Okay. Now this is still pointing to 5, right? So this is right. We redraw this, right? So 4 is pointing to 5. 4, even though it was moved here, it's still pointing to 5. So that's what this line does. This sets it to null pointer. So now 4 is pointing to end for null pointer. And this is the start of the new list. 5, 4, right? Because we're trying to reverse it. And it returns new head. So 5 is now passed up the chain to 3, right? We want this so we can tell what part, right? Where is the new start, right? Which is the old end of the list is the new start. And the same thing now happens again for 3, right? We finished with 4. Now the same exact thing happens with 3. And 3 is pointing to 4, right? That crosses out. Right now it's technically pointing here, right? That crosses out for better visualization. This stays the same, even though it moved over, right? Figuratively, it's still pointing to 3. 3 is still pointing to 4. Right? So this line runs again for 3. Head next. Head next. So now 3 becomes where null pointer was, the new end of the list. 3. Right. And the same thing happens again for null pointer. Null pointer. Because otherwise it's still pointing to 4, and that doesn't make sense, right? We don't want it to point to 4, right? You see 3 always points to 4, even though it also moved, right? Technically. The pointer still points to it. So we just go up the chain, right? So 4, 3, 5, 4, 3, 2, 1, right? And now, once we get to the original instance, this is the original time this function was called, we return new head, which is 5, because it's been passed up all the way up the chain. The old tail is now the new head. And that is reversing a linked list using recursion